On this problem, we need to determine if the function below is one-to-one by noting the function family to which it belongs and mentally picturing the shape of the graph. If it's not one-to-one, discuss how the definition of the one-to-oneness is violated. So think about the family. The parent function is this. And then that plus 1, since it's with the variable, that means it's a shift. It's a horizontal shift in the opposite direction, so it's a left shift of 1. And this minus 2 tells us it's attached at the end. It's not with the variable. So it's a vertical shift, and it has the same sign, so it's a shift down 2. But let's start with the parent function. So I have in my library of knowledge that is a, oh, that's actually cubed root, sorry. That is a cubed root function. Well, what if I don't have that in my library knowledge and I'm not really I don't quite remember what that looks like? Then I can always throw a couple points out and try to jog my memory. So for example, I could do, let's do, this is my y-axis, my t-axis. I think 0 is always a good one. Let's do 0 and maybe -1 and +1. Let's do maybe -2 and +2 also. And hopefully just doing a couple points will jog my memory of what that looks like. So let's pretend I don't remember. I don't have that in my library of knowledge. Okay, so when I plug in -1, I'm looking at the parent function right now. I plug in -1. Oh, I know I can't. Oh, yes, I can. It's cubed root of -1 is also -1. -1 cubed is -1. So at -1, at t equals -1, y equals -1. At 0, when my t is 0, my cubed root is 0. At +1, my y, this is going to be, so I should be plugging these in here. So when I plug in -1 for t, then I should, not y, this is r, isn't it? I get -1, I plug in a 0, I get 0. When I plug in a 1, I get 1. Plug in a 2, that's not as easy as let's do a cubed root. Let's do -8 and +8. Those are a little easier. So when I put in 8, t equals 8, that's the cubed root of 8, which is 2. -2. And the cubed root of +8 gives me a +2. So I'm starting to see a pattern here. So when t is -8, r will be down here, and similarly over here. So that's starting to look like a shape. And I do recognize that shape once maybe I warm up my library knowledge there. Okay, so I have that parent function. So that's what they mean by the function family. Think about the shape of the function. And then I'm going to think about my shifts. So when I start with that parent function and I add something on inside the parentheses with t, that means to shift the opposite, shift in the horizontal, I should say horizontal shift in opposite direction, opposite of the sign. So we have a +1, which means this, we can use that center point to shift the whole thing. Kind of like think of it as like a little landmark. Shift that left 1, so that's going to land there. But then I also have a -2. And since that's tacked on to the end, that is a vertical shift in the same direction as the sign. Horizontal always goes in the opposite direction. The vertical is going to go in the same direction. So that says -2, so it's going to shift down 2. So the center point is now right here. So our curve looks something more like this. But the shape does not change. If the parent function is 1 to 1, well then this shifted function is also 1 to 1. It's just shifted. So and let's see, is it 1 to 1? I can draw vertical lines, so I know it's a function. And I can draw horizontal lines, and I never cross the graph more than once. So that means it is a 1 to 1 function. So vertical line test says it's a function, and the horizontal line test says it's a 1 to 1 function.